So just a hint as you're doing these, if you want a hint. First one, U-Substitution. Second one, there's a few methods of doing that. But remember that if we've got a fraction, we can break that up into two fractions. So that's my hint. So just quickly going through this one, you can see that the answer for the first one is -1/6. Now, what we've done is we've done a U substitution. I've let U equal cos 2x. I then find du dx, which is -1/2 sine 2x. Since I've already got sine 2x there, then I can put that constant of -1/2 out the front. But be careful. When I go ahead and do a U substitution, I need to evaluate what U is when x equals pi on 2 and 3 pi on 4. Be careful though, when you go from this step here, to the next step, you do not go ahead and change the terminals until you write that du dx, and then once you change or cancel out those dx's effectively, that's when you're changing those terminals. And of course those terminals for me was -1 to 0. Now I guess you could have flipped them around if you would have liked. You could have flipped them around and cancelled out the negative and made it 0 to 1. Either way, I've just done it that way. And the answer there of -1/6. So can I just get a show of hands? I'll just pause it for a sec. And very quickly, now there's a couple of methods for this. You could have done partial fractions straight away. But what I've done is I've basically said that is equal to, you would never do anything what I'm just about to do. I'm doing it to save time. But that is equal to 9 minus x squared, 1 over 9 minus x squared dx, plus x over 9 minus x squared dx. Now, you do partial fractions on the side. Now, I'm not going to do the algebra of that right now because I'm in the interest of saving time. But what I've got is I've got a equals 1 over 6 and b is equal to 1 over 6. And that is for the algebraic fraction of this. So we've got a over 3 minus x plus b over 3 plus x. Okay, so that's what I've got. You might have done it the other way around, but you'll still get the same values for a and b, or you should. So therefore, that is equal to now I've taken the 1/6 out the front. I've got 1/6 outside of 1 over 3 minus x plus 1 over 3 plus x dx plus the antiderivative of that is going to be, well, look, let's just write it out here actually. X over 9 minus x squared dx. Now, as it turns out, if I take that and I use my log laws, that gives me 1/6, and that is going to be log e to the 3 plus x minus log e to the 3 minus x. Using my log laws is going to give me this, but what's important is that you have those absolute value sign, and you can't omit that. Okay, they've given, now think about it. They've said that that it's real numbers except for -3 to 3. So that could possibly be negative, couldn't it? So we need to keep that absolute value sign. Now, the second one is going to be fairly straightforward because we know that the derivative of 9 minus x squared is minus 2x, and we've got x on the top. So if I was to multiply that through by -1/2, then that's going to be my constant. So what we've got is this. And that's the answer. Now, other things would be accepted. People would stuff around trying to simplify that. I wouldn't waste your time because it says find an antiderivative of that. Look, yeah, you could simplify, but it's going to take you another 2 minutes. And if you balls it up and screw it up, then you lose marks. So just stop there. Okay? Importantly, stop. Because you're not required. If it says answer it in this form, then you have to do some simplifying. But just don't go any further. If you went further and screwed up, you'd lose marks. If you stopped there, you'd get your full marks.
But with the absolute, we lose marks.
Absolutely. If you don't have the absolute value sign, you'd only get 2 marks. All right? Now, look, I'm going to show you the examiner report for that. Let's have a look. Now look, students did fairly well in this, but it was quite evident that a lot of students, so 39% of students got 3 marks for that. And as you can see there, I've left it in this form, and it says other equivalent answers were accepted. Things such as this, depending on if you did partial fractions in the one hit. These questions were quite well done. What does it say? Errors seen including using denominators and omitting modulus signs. So you wouldn't get your full marks. I don't know. Maybe they'd give you 1, 2, I don't know. All right, so I'm going to pause there, and I'd like you guys to have a go at the next session, which is session 6. Can I ask you though, when you turn over that page, I'm not going to make it 20 minutes anymore, because the mark that has been removed has been not the second page, it's this one, this rough incline. That is an limiting equilibrium one. So can you cross that one out, which is 4 marks? And I'm going to give you, there's 8 marks. Look, I'll give you 11 minutes to do that, but I reckon it's a pretty easy 11 minutes. I reckon you could do this in 5 or 6, these marks. So away you go. I'm going to pause it now. Have a crack at it, please. All right, now, my hint with this is always label this direction of motion. So you should have done something like this, and that's just more to prompt you of which way is positive. Because on the right side of the pulley, up is positive. On the left-hand side, down is positive. So I've got 2 equations. There needs to be some evidence of your 2 equations for your mark. And I've basically said that on the left-hand side, 3g, down is positive on the left. 3g minus t. And that is equal to 3a. And where a lot of students screw up is that force equals ma. On the left-hand side, the mass is 3, so it's 3a. On the right-hand side, the mass is 1, so 1 kilogram times a is a. Then you add those together, and then that gives you a equals g on 2. Can I get a show of hands that got that?
Can we leave it as 4.9?
4.9 is acceptable as well. Absolutely. Now, for the second one, you then need to substitute your value in, and or substitute that into one of the equations. I substitute that in equation 2, and that gives you 3g on 2. Okay, now, if you couldn't do part 1, though, you really couldn't do part 2.
Wait, is T1 in newtons or meters?
Newtons. Yeah, okay, that's my bad. That would actually pretend, that'd lose me the mark. That would lose me the mark. So, there you go. I just dropped a mark. All right, the second one. Now, this time for the next one, we have the same thing, the direction of motion. Label that please, because that means that tension is positive about the 1 kilogram mass, and it's for the other one, it's going the other way. So, but we've had a look, and you can see there that I've got the 2 equations, and then once again I'm adding those equations. Being able to resolve forces parallel to the plane is something that if you're struggling with, you're going to lose a lot of marks. But it's a pretty straightforward process. So I've added those 2 equations together because those t's are opposing. That gives me 4a is equal to 3g sine of 30 is 3g on 2 minus g, and that gives me g on 2. So therefore my acceleration is g on 8 meters per second squared, which means that b is equal to g on 8. Okay? And for the last one, it says here for the rest that it's rests on the plane. That means it's in equilibrium. So I've resolved about the 3 kilogram mass, which means that's going to give me 3g sine of theta minus t is equal to 0. That gives me an equation of t equals 3g sine theta. I'm then going to go about the 1 kilogram mass, and that means that I've got the direction of motion. Forget about that direction of motion now. Don't worry about that. It's not going anywhere. But what we can say is that t is equal to g, because otherwise they wouldn't be in equilibrium. So therefore, subbing t equals g into equation 1 is going to give me g is equal to 3g sine theta. So you could do this by hand if you wanted to. There is 2 marks, so there has to be a method mark. You don't have to do all that by hand. You could just solve in a CAS. Once you show the working, you could go CAS solve, and that would then solve for 19.5 degrees when rounded to 1 decimal place. Okay, now as I was saying, look at the I think this was 2007 exam. If we have a look, part A was clearly done fairly well. But look at that, 31% of students would have screwed up the sign and they wouldn't have been able to add the 2 equations and cancel out the t's. So if you're dropping these marks, then you clearly haven't studied hard enough on this. Connected particles are very straightforward. This example in particular. So the second one, have a look at that though. That's really polarised. Those students that couldn't do the first part, only 61% of students got that mark. The third part, well, once again, you could either do it or you couldn't. Not too bad. 42% of students got full marks for that. And there was probably a fair bit of sloppiness there, and a lot of students would have dropped the marks and not got full marks. And the last one, yeah, I'm pretty surprised by that. I would have thought that's a fairly straightforward question. But 42% of students got 0. Just a bit over half the students got 2 marks. But it was a pretty straightforward question. Now let's have a look at the third part, and remember that when you see these have been removed from the course. But I'm a bit ashamed because I think that should stay in the course. But as you can see, that last part, which we've been through the theory of that before, 49% of students got 0. And, well, 73% of students really could only muster, at best, 1 mark. So, I guess for some of you, you're probably glad that that's out. All right, so I'm going to just stop that there, and we're going to have a go at Session 7, please. Have a go at Session 7. It's just the 1 page. There's 6 marks, and I'm going to give you, says here 8 minutes. I will give you 9 minutes, but I really do think you could do this in about 5 or 6 if you really know your stuff. All right, so I'm going to pause this now. Away you go. Have a go. So, just quickly, state the maximal domain. Now, we've been through some of these already, but it's important for you guys to know, and not by looking at the formula sheet, that the domain of cos is between, inverse cos is between -1 and 1, which means that 1 minus 2x must be between -1 and 1. Then what we're going to do is we're going to subtract 1 from both sides, divide by -2, which means that the domain is going to be x is between 0 and 1. Okay, so that's going to be your first mark. How you do it, up to you. The second mark is, you could do one of 2 things. You could say, okay, when x equals 0, then we could say that y is equal to the inverse cos of 1. Now, where does cos of what gives me 1? 0. So that's equal to 0. What about when cos of what gives me -1? Because obviously when we sub 1 in, that's going to be cos of 1 minus 2, which is -1. So that is equal to pi. So that is actually my range. My range is 0 to pi. Now, by the way, the range actually hasn't changed. Okay? The range hasn't changed if you just look at the transformations. All right? What have we done? Think about it. 1 minus 2x, isn't that a reflection in the y-axis in terms of the shape? And we haven't actually done anything in terms of affecting the range. But let's have a look just quickly at the shape. Now, we've found the endpoints, but cos of x inverse cos of x is going to look something like this. Now, inverse cos of x is a reflection in the y-axis, so it's going to look something like this in terms of shape. And then as it turns out, then we've moved that across. Now, you can actually say, we said when x equals 0, y is equal to 0 as well. So we've got a starting, when we're sketching this graph, we start there, and it's been squeezed a little. But either way, that shape that shape is going to look something like this. Now, what's the end? It says label the endpoints. We know this endpoint, 0, 0. We just worked that out there. When x equals 1, y equals pi. So therefore, that's going to be your mark. Now, in order to do that, you would have had to get the answer would have been for both endpoints being correct and labelled properly. Just out of interest, there's actually a point of inflection there. Now, that's not required, but if you went ahead and actually tried to state where a point of inflection was and it was incorrect, you'd actually lose a mark. So don't go doing anything crazy that you're not needed to do. Think about it. A point of inflection, given there's only 2 marks, we've got 2 endpoints and a shape, not necessary. But if they asked for the point of inflection, we could do that, couldn't we? So there you go. There's your 1 mark for the answer. The shape is also worth 1 mark. But getting an idea on the shape, as I said, working through the transformations could also help you. Now, just quickly, it says find the gradient of the tangent. Now, I'm going to do this, when you're doing these, guys, until you're getting them bang on every time, I'm going to say do it this way. We're going to let u equal 1 minus 2x. Because therefore, du dx, using the chain rule, is equal to minus 2. Now, y is equal to the inverse cos of u. And the reason why it's good to do it this way is because the formula sheet you can then utilise. You can't utilise the formula sheet with more tricky functions. So dy du, using the formula sheet, is negative 1 on the square root of 1 minus u squared. Now, dy dx is equal to, multiplying those through, is equal to, well, I've got 2 over the square root of 1 minus. Does anyone give a hoot about this? Like this. Now I don't have to evaluate that on paper, but I can then do it in my head. 1 minus, that's going to be 1 minus 1, and it's going to be a negative and a negative 4x, so that's going to be a positive 4x. So I'm just going to go straight to this step. That's going to be 4x minus 4x squared. Taking 4 out as a common factor, that's going to leave me with 2 over 2. Yeah, so that's going to give me 2 over 2 x minus x squared. Now, Matt, what?
Can you just leave it that way and just do the evaluation?
Yes, absolutely. Absolutely. So now I've found my expression for dy dx. You could have done it a different way, but when x equals 1/4, subbing that in, you should get something like this. Dy dx is, I got 4 on root 3. Now, you could have rationalised the denominator, not required. Can I just say, though, that if you have a fraction over a fraction, that is not acceptable. So if you had something like this, I'm just going to make something up, 4 over root 3 or something like that. Not that that's the same thing, but if you had something like that, that is not, you wouldn't get an answer. It needs to be some answer as a fraction. 4 over root 3 or 4 root 3 on 3. Okay? All right, I'm going to stop there and we'll resume.